Anya. I beg your pardon. Okay, lovely, everybody. All right, so let's get started. First of all, can you see the diagram and the information that comes with the diagram? Can you see that okay?
Ma'am, please zoom it in.
Zoom in a little bit. Okay, I'll just move that over. Is that a bit better?
Yes, ma'am.
Okay, so I've got the questions on the side here so that we're able to work underneath, but obviously we're going to have to sort of go up and down a little bit to just sort of make sure that we get everything in. Okay, so we always start off by reading the information that's been given and then looking at the diagram and then worrying about the questions. So it tells us in this particular question, which is from one of the end of year papers in a November paper 2014, it says in the diagram ABCD is a parallelogram. The diagonals of ABCD intersect at M, so that's there in the center. And just highlight M. I'll do that in yellow. Here's M over here. F is a point on AD such that, so here's F over here, such that FD is to AF is 4:3. So this is 4 and that's 3. And because these are along the same size and they're along the same line and they've given us a ratio, what we could actually do is we could call this one 4x and we could call this one over here 3x. It says to us E is a point on AM such that EF is parallel to BD. FC and MD intersect in G. All right, so in other words, they meet one another at G, and this is point G over here. Again, I'll just highlight it. There's G over there. All right, so this is important. They've given us a whole lot of parallel lines. And the minute we start seeing parallel lines, what do we start thinking about? What have we been doing over the last couple of weeks?
Proportionality theorem.
Proportionality theorem. Okay, and we've also been talking about proving triangles are similar, but this specifically relates to proportionality intercept theorem. Okay, because we've got triangles and we've got parallel lines. All right, so they've given us one ratio. We know that AF over FD is 4/3. They want us to calculate, giving reasons, the ratio of EM over AM, right? So let me go and highlight those sides. We'll use a different color, all right? So here is EM, and here is AM. Okay, so it's the little blue bit over the pink bit. Where do you think our solution to this comes from? What triangle are they asking us to work in?
Triangle AMD.
AMD. All right, and we can work in triangle AMD because we have
two sides.
Well, a line. Okay, so a line in this case being the line EF that is parallel to line MD. Okay, so it's going to cut the remaining two sides, in other words, sides AD and AM, into the same proportions. Okay, so we're working in triangle AMD, lovely. And what are we going to say about EM over AM? Or, well, first before we let's work, what can we say about EM over AM? What is it equal to?
FD over FA.
FD over FA. Good. Okay, so EM over AM is going to be equal to FD over the whole side, which would be AD. Does that make sense?
Yes, ma'am.
Okay, all right. So you just named the wrong side there, but it's not the end of the world. Okay, so what we're doing here is we're then putting this over, just change the color. That one. Does that make sense? Okay, I think the colors. I think the colors help. Okay, so we've got EM over AM is equal to FD over AD. All right, and our reason for that is because of?
Prop and theorem.
Good. And what must we not forget to name?
The parallel lines.
The parallel lines, quite right. So in this case, it's because EF is parallel to ED. Okay, or we could have said MD, it wouldn't have mattered, it's the same thing. Okay, all right, so now that we've made that statement, we can go ahead and write down what EM over AM is equal to. We know that EM is, what's EM, Matrix?
3x.
It is, it's 3x. And we know that AD is?
7x.
7x, absolutely. And of course, x divided by x means it's actually 3 over 7. Okay, everybody happy about that? No problem, Siatemba. We're glad you can join us. Is that all right, Matrix?
Yes.
Okay. So you can see this particular question, if you can see now on the screen, that was worth 3 marks. What do you think they're giving you those 3 marks for?
For reason.
For statement, for reason. And if you forget to name the parallel lines, you're going to lose this mark over here. So don't forget about the parallel lines. And then you're going to get another mark for your answer. Indeed. Okay. All right, let's try 1.2 now. I'm going to do that on the other side. Sorry, I'm really kind of writing all over the place here. So that was 1.1. Let's just make this pen a little bit narrower. Okay, there we go. We're going to do 1.2 over here. So in 1.2, they want us to write the ratio of CM over ME. Okay, so let's go and get another color highlighter and go and highlight those lines so that they can stick out to us. Okay, so where is CM? Okay, CM is this line over here. So CM over ME or EM. All right, CM over ME. Anybody want to take that one? What would CM over ME be equal to?
CG over GF.
CG over GF. Good. Reason?
Prop and theorem.
Okay, this actually should be written over here. And that is because EF is parallel to BD or MD. Okay, so this line over here is parallel to that one over there. That's why we can say this. Okay, so now saying that it's equal to CG over GF, do we know anything about CG and GF?
No.
No. Okay, so what we've said is true, but does it lead us to a solution?
No, ma'am.
No. Okay, so maybe that's not the way that we need to get to the answer. All right, so when something like this happens, don't say, oh, I've gone wrong, I've gone wrong, I've gone wrong. There's just something else going on here that we haven't actually seen yet. All right, so what else could CM over ME be equal to? Well, let's put it this way, right? They told us that this is a parallelogram, didn't they? So all the properties of parallelograms apply in this situation. So what can we say about CM and AM?
Since the diagonals bisect each other, then AM is equal to CM.
It is indeed. Okay, so whilst this was true over here, this didn't actually lead us to a solution. Okay, it's very true, but it's not going to help us in this particular case. So CM is equal to AM. Our reason here the diagonals of a palm bisect. Okay. So now CM over ME has to be the same as AM over ME. All right, so that has to be in this case 7 over 3. Does that make sense, Matrix?
Yes.
Yes, it
No,
does.
ma'am.
Okay, so Tabila said yes, but I think somebody else said no.
Yes, ma'am, I don't understand. Can you please repeat again?
Sure. Bonolo, where did I lose you? What am I saying that you're not understanding?
The diagonals of a palm bisect, ma'am, I don't
Okay.
understand.
Okay, so that is one of the characteristics of a parallelogram. So I'm just going to jump over here. Don't worry, we'll go back to the diagram now. All right, and if I draw a parallelogram, I'm probably not going to draw it very well, but I'll do my best. All right, if I draw a parallelogram over here, okay, what makes it a parallelogram, all right, is that by virtue it has two pairs of opposite sides that are parallel to one another. Those sides also happen to be equal in length, but really a parallelogram is defined by the fact that it has two pairs of opposite sides parallel to each other, right? So when we talk about the diagonals bisecting, a diagonal is a line that goes from one corner to the other corner, all right? And then it would be the same on this side of here. So from this corner over here to that corner over there. So the word bisect, in English, sect means to cut, and bi means to cut in half. Okay, so that's why we would say that the diagonals of a palm bisect one another. So what that means is that this line segment from here to here is the same as from here to there. Okay, so the pink line cuts the black line in half, and the black line cuts the pink line in half. Does that make sense to you?
Yes, ma'am.
Okay, you happy with that? Ooh,
Yes,
what have I
ma'am.
done
Thank
here? Okay. All right, so now let's move back. What am I doing? Okay, let's move back here. Okay, so now you're happy with CM equals AM, diagonals of a palm bisect. So AM
Yes.
over ME was 7 over 3. Okay,
Yes.
it's just the other way around of what we've already worked with in 1.1. And that's why CM over ME is equal to the same thing. All right, we're all happy there. Again, this was out of 3 marks. Okay, so there's going to be a mark matrix for the statement, the reason, and the answer. Okay, let's have a look at the next question. And I chose this question on purpose, right? They love to ask this. The area of triangle FDC over the area of triangle BDC. Now tell Anya and I, who of you have seen that before in class in questions? The area of one triangle over Tobile, you've seen
Also
it?
me.
Also you?
Also me.
Anybody else? If you want to put it in the chat, you're welcome to.
Also me.
Also you, Boypelo, okay.
I've also seen it.
You've also seen it, September. So is Zintle, so is Jane. Okay, Jamie, when you were doing past papers, Lesedi's seen it, Zia's seen it, Dintle's seen it.
I've seen it too, ma'am.
You've seen it too. Okay, so yes, this is something that comes up. It really is worth us discussing. Okay, so the idea behind a question like this, right, is that they really want you to write a ratio using the area. Now, in matric, there are 2 ways that you can get the area of a triangle. Can you name one of them for me? What's one way that we get the area of a triangle?
Half times base times height.
Half base.
Beautiful. Okay, so the one way that we can do it when we get to matric, all right, is that the area of any triangle is going to be half base times perpendicular height. Okay, so very important, that word perpendicular. All right. What's the other way that we can do it? Not that we're going to do it that way, but there's another way we can do it as well.
Length times breadth.
Say that again.
Length times breadth.
Length times, good option, but length times breadth is for a rectangle. Yes, Siatemba.
Another way is you say half times A times B times sine C.
That's it. Okay, so that's the area rule. Do you remember the area rule from trigonometry?
Oh, yes.
Okay, so that sometimes comes up as well, and it's exactly as Siatemba said. So it actually comes from this formula as well. So it's half, and then it's the one side. Okay, so let's call it side B. Then the other side C, and then it will be the sine of the angle that is in between. Okay, but we'll talk about that. I'll do an example like that with you guys. I don't know if I'll do it this lesson, but we can talk about that later on. This situation in number 2 works when there is a common angle. So if angle A is in one triangle and angle A is also in the other triangle, then you can use the area rule. But in this particular situation, if we go back here and we have a look, we'll see that there's no common angle. All right, so that means the area rule is not going to work in this case. Okay, so let's highlight these triangles so that we can see exactly what it is that they're talking about. Okay, so triangle FDC. So that's this guy over here, FDC. Ooh. Oh, what sort of straight line is that? Sorry, guys. Okay, there's triangle FDC. I've highlighted him in green. And now triangle BDC is this guy over here. So let's make him pop out as well. So this is triangle BDC. And then that's its side over there as well. So they both share side DC. Do you think that's important? Do you think it's important that they share DC? Hang on a second, Lorato, you said, ma'am, is the formula B? Okay, so the formula base times height, that's for a parallelogram. But yes, that is what we're going to use in this case. We're going to use half base times height.
I think what might have confused Arata there is I know some students might write half times base times height. Some students say base times height divided by 2. It's the exact same formula.
Yes,
so I think you just misunderstood my message there, Aratu. But like ma'am said, now base times height refers to parallelograms, and that. Back to you, ma'am.
Thank you so much. Okay, so what we notice, and maybe I should have a little bit of a discussion with this on the side over here, all right, is that if triangles are drawn between the same parallel lines, so let's draw a line over here and let's draw another line over there. Now I'm going to come along and I'm going to draw a triangle over here. All right, and then I'm going to come along and I'm going to draw another triangle over there. Right? Because these triangles lie between parallel lines, that means what about them is exactly the same?
Their height?
The height, exactly. So the perpendicular height. Right, so because they lie between the same parallel lines, their perpendicular heights are going to be exactly the same. Right, this is a very important concept for us in grade 12. Right, and that's what's going on here as well. If we go and have a look at our diagram, can you see that they both lie between AD and BC? So the distance from line AD to line BC is common for both. That is the perpendicular height. Does that make sense to everybody?
Can you please repeat that?
All right. So in other words, if I was to take a straight line from FD to BC, now this is a perpendicular line, right? Can you see that the perpendicular height of the light green triangle and the dark green triangle is the same because they lie between the same parallel lines? Okay, so that's the same, all right? So in other words, the height of triangle FDC is the same as the height of triangle BDC, all right? And that's because AD is parallel to BC. Okay, now that's important because they're going to give us a mark for that. Okay, so we have to state it, right? Because that's why it's true. This is the reason why it's true. Okay, so it has to be stated. Okay, so area, woo, what am I writing? Area of triangle FDC over area of triangle, what was it? FDC and BDC. BDC, that's it. Thank you. BDC is going to be half base times height. Okay, so half. Now, the base of triangle FDC is the line. What's the line, Matrix? The base.
FD.
FD, good, well done. Okay, times by the perpendicular height. Excellent. And then at the bottom, we've got half base times height. The base of triangle BDC is?
BC.
Excellent. BC, well done. Very nice. Okay, times perpendicular height. And in maths, anything divided by itself is?
1.
Beautiful. Anything divided by itself is 1. Okay, anything divided by itself is 1. Okay, so we no longer have the halves and we no longer have the heights. And what we're left with, Matrix, is FD over BC. That's the ratio that they wanted.
BC.
Okay, FD over BC. FD over BC.
Ma'am,
Yes.
may I jump in here and just make an assumption for note for the students? When you get a
Sure.
question like this, will the probability be quite high that that ratio that you write, in other words, I think we wrote FD over BC, will those lines always be parallel? Because that's something for students to look out for as well.
Yeah, well, you see, the thing is, they told us in the beginning that it was a parallelogram.
Yes, yes.
Okay, so because line AD is parallel to line BC, that is what makes this situation possible.
Yes.
Because triangles that lie between the same parallel lines will have the same perpendicular height.
No, okay, cool. So I just want
Yeah, but
students
yes.
to check that, because if, for instance, they wrote DC over BC, those lines are not parallel. So that's also just something
Yes.
to check. Yeah, just something for the
Yes,
students
yeah.
to note.
Absolutely. So in other words, what you've got to look at here is that if this is, so the purple line is the perpendicular height. So where the line cuts the side of the triangle at a right angle, that's what makes this the base. So if this is the height here, this has to be the base. So if this is the height over here, this line over here has to be the base. Okay, does that help?
Yeah, I think the students, I just wanted to mention that just for fact check, but
Yeah, no, 100%.
but students, do let us know if that helps, or if you guys are still a bit lost or so.
Okay, and then we know from what we've already done that FD has a ratio of 3, and BC has to have a ratio of
7.
7. Okay, what we will just need to add in here, okay, is that BC equals AD because they are the opposite sides of a palm and they are equal. Okay, so that's where we would get the 3/7 from. Okay, so how are you feeling? You can unmute your mic, or you can put something into the chat for Anya and I. Tell us how you're feeling about this question.
At ease.
Cool. No, Lorato, you are not supposed to be doing any constructions unless you are proving something. Okay, so when you need to do the proof of the theorem, so if they ask you to prove the proportionality intercept theorem, then you construct. You do not construct otherwise. Okay, the only other time that you would construct in maths is sometimes in analytical geometry. We're allowed to join one point to another to make a right angle triangle. But other than that, you're not doing constructions because this is not a proof. It's not a proof of the theorem. Okay, so yeah, no constructing of lines. Are there any questions that you want to ask?
Ma'am, why did I draw a line between FD and BC?
Oh, I was trying to show you, Cassandra, that that was going to be the perpendicular height that was the same for both. All right, it wasn't a construction. It was me showing you that the perpendicular height is the same. So do you remember over here we wrote H and H?
Yes.
Perpendicular height, that's this line here, the perpendicular height.
Okay, thank you, ma'am.
Okay, so it wasn't a construction. All right, does that make a little bit more sense now?
Ma'am,
Yes.
we have a question in the chat from Sasanda. She asked, when would we use when it's an included angle? Remember before we started this, you mentioned about 2 triangles of included angle. They just want to
Yes.
check, when would we use that then?
Okay, so it would have to be a situation where they shared the same angle. Let me try and sort of think of a situation where I could draw that for you. They need to share an angle. They need to share an angle.
You can extend those triangles, can't you? So that the middle one at the right bottom, so that they're basically on top of one another and the one's just larger or more extended from the drawing you just made.
Probably, that probably would be the easiest thing to do actually. Is to, if you go something like that, so there's your parallel lines, and let's say you've got a smaller triangle over there, and then you've got a,
and it can even overlap, yeah, like that,
larger one,
and then
like that.
and they're not necessarily similar also, it's just,
yeah. So what we're talking about in a situation like this is that there has to be, the angle has to be in both at the same time. I've actually got an example of that. It's in this book over here. Let me see if I can quickly pull this up and then I can show you what I mean. There it is there. Okay, just give me 1 second and I'll actually show you an example of this. I just need to pull this question. I just need to pull this question up. It's not
That's
something that I
fine.
actually had planned for tonight.
While
Okay,
ma'am is looking for that example, if you guys or girls have any concerns or so you'd love to share, please share, post in the chat so long while ma'am finds that example for us. If there's anything that you feel a bit uneasy about, so please let me know. You can also unmute yourself. So I think also just to reiterate what I mentioned in the chat with what ma'am spoke earlier about when we have the area of one triangle on top of area of another, what you basically, the reason why ma'am wrote that line there of the height is to first, she tried to distinguish, is this the height? So in other words, is it, are both triangles is like, are they both the same height? Or that, you know, they're both the same. Oh, I can't English today, apologies. So we first do that, and then basically we use our old school area formula for a triangle, and we just substitute, and then we just simplify that, and whatever's left will be our ratio essentially. So that's like a step-by-step analysis of how to do that.
yeah. Thank you, Anya. That's perfect. Okay, let me just have a look. Yeah. Ha. Okay, I have found the question. I just need to take a shot of it. I'm going to make this bigger. can I? Okay, I can't move that out the way. I've got the question, but unfortunately, the place where you would then zoom in is grayed out because I'm doing this with you. Okay, I don't know if I can get in there. Oh, there we go. All right, hold on a moment. Okay. No, I can't make it big enough to be able to take a picture of it to go and stick it on the screen. You know what I'll do? I'll make sure that in our next lesson I've got it, because I know exactly where it is, and then I'll show you what I mean by that, and then I'll show you what we do with the area rule. Okay. I just don't want to waste time this lesson looking for something. All right, so let's carry on. This question is a little bit more difficult, all right, but again, this is something that comes out of a past exam paper, so this is the sort of thing that you can expect at the end of the year in your NSC exams as well. All right, so we always start off by reading the information and then looking at the diagram and then going and having a look at the questions. So it says to us, in the diagram below, EO bisects side AC of triangle ACE. EDO is produced to be such that BO equals OD, and they've put that onto the diagram for us. AD and CD produced meet EC and EG at G and A respectively. Okay, so they're just telling us that lines have been extended to meet at another point. Is this diagram big enough? Shall I make it a little bit bigger? Is that better? All right, and then I'll just slip the questions in over here. All right, so in this question, the first thing that we're asked to do is to give a reason why ABCD is a parallelogram. Okay, so I'm just going to highlight ABCD for you, and you think about that just while I draw these lines. Why is this a palm?
Because BD bisects AC, I think.
Lovely. That's 100% perfect. Well done. All right. So the reason that it's a parallelogram is because the diagonals intersect the diagonals bisect one another. Okay. So diagonals of a palm bisect. Let's write that down. So the diagonals of a palm bisect. Okay. So that will get us 1 mark. Okay. Next question, 2.2. Write down with reasons 2 ratios each equal to ED over DB. Okay, so let's get another color and highlight ED over DB. Okay, so here's ED, and here is DB. So it's that whole line over there, right? Remember, ABCD is a parallelogram, okay? So that means that side AB is parallel to side CD, hint, hint, hint. And it also means that side AD is parallel to side BD. BC, sorry, beg your pardon. Yes, BC. So look for a triangle. It can be difficult to see in this situation. You need me to help you see the triangles we're working in?
I think it's BAD.
AB, AB,
BAE.
that's it.
E.
BAE.
Okay, so if we have a look at here, what I'm putting here in orange, the reason that we can work here, and it's difficult to see this, is because this entire line, CD all the way to E, is parallel. Okay, so can you see here, Matrix? This line that I'm coloring in purple is parallel to this line over here. Can you see that?
Yes.
Yes,
Can you see
ma'am.
it a little bit better now? And can you see ED over DB? And then on the other side, we've got EF over FA. All right, Buhle, you raised a hand. What's up?
Ma'am, would it be incorrect if I chose triangle BCE instead of BAE?
BC. No, you're quite right. You're quite right. There's a ratio in there as well. And that's why they've said to us, write down with reasons 2 ratios each equal to ED over DB. So there's 1 in each of these 2 triangles. Okay, so nothing wrong. Well done for spotting that. Okay, so when we get there, I want you to tell me which side. Okay, so if we look in the orange-purple triangle, we would say that ED over DB is equal to what matrix?
E.
Uh-huh.
FE.
FE over
That's
A.
or over AF or FA. Lovely. And our reason for that?
line
Prop
drawing.
and theorem.
Prop and theorem, or line drawn parallel to one side of triangle. Okay, so if we're saying prop and theorem, we must not forget to name the parallel lines. Okay, so that's because BA is parallel
BA is parallel to DF.
Yes, or CF, perfect, 100%. Okay, so that would be 2 marks, 1 for the answer and 1 for the reason. Okay, so now working in the other triangle matrix, we've got again, ED over DB is equal to what? The young man who was talking earlier, do you want to say the answer?
Ma'am, would it be CG and GE?
CG and GE, very good, well done. Okay, so ED over DB is going to be the same as EG over GC. Can the rest of you see what Buhle is talking about here? I can highlight the triangle for you. I know there's a lot going on here. I can rub all of this off, but he's working in this triangle over here, okay, that I'm busy coloring in green. And he's saying that this side over here, side BC, and this side over here are also parallel to one another. Okay, can you see that matrix?
Yes, ma'am.
All right, so that means that we need to provide a reason. Again, we're going to say proportionality intercept theorem, or for those of you that prefer to say line parallel to one side of triangle, that's not a problem. And here it's because BC is parallel to AG or DG, same story. Okay, so again, there would be a mark for our answer and a mark for the reason. Okay, next question, they say to us, prove that A1 equals F2. All right, so I tell you what, let's try and clear some of this up because there's an awful lot going on here. Let's just put the parallel lines back in. Get rid of all of that. It was confusing. And let's just pop in our parallel lines. So remember, ABCD is a parallelogram. We proved that in question 2.1. So side AB and side CD are parallel to one another, and sides BC and AD are also parallel to one another. Okay, so where is angle A1? Okay, it's over here. There's A1. All right, and where's angle F2? All the way over here, right? So when they ask us to prove that 2 angles are equal to one another, what usually happens is that there is something that there are another angle that they are both equal to, right? And we need to find what that angle is. So we need to try and create some kind of connection here between angle A1 and angle F2. So let's start with A1, all right? What is A1 equal to?
C2.
Okay, it's equal to C2. Nice. All right. Is F2 equal to C2?
Yes.
Yes.
Why,
Ma'am.
Watobe? Why are they equal?
Alternate angles.
Okay, but is line AC parallel to line FG?
Oh,
Ah,
no.
no. Okay, so it would be, okay, C2 would be equal to F2 if those lines were parallel. Okay, so maybe now what we need to do is we need to show that line FG and line AC are parallel to one another. Because if we can do that, we can prove that C2 and F2 will be equal, and then therefore that A1 and F2 will be equal to each other. How do we prove that lines are parallel?
Ma'am, isn't it that ACGF is a parallelogram? Firstly, because AG FC.
So ABCD is a parallelogram, absolutely 100% right. But that doesn't prove that AC is parallel to FG. Right.
Okay.
And this is the thing with geometry. Often what we've already done helps us in the next step. So if you get stuck on something like this and you say to yourself, what is the connection between these two? What have you already worked out? Well, you know that ABCD is a parallelogram. Great, that doesn't help us. What was the other thing we worked out? Oh, yes, ED over DB is EF over AF. And ED over DB is EG over GC. What do you think question 2.2 is trying to tell us? Can anyone make a deduction based on what we see in 2.2?
That EF over AF equals to EG over GC.
Ah, Jamie, well done. So that EF over AF is equal to EG over GC. Do the rest of you see that, Matrix?
Yes,
Yes,
ma'am.
ma'am.
All right, so because they're equal to the same thing, in other words, ED over DB, they must be equal to one another. Okay, all right, very, very important. Okay, we don't have to provide a reason for that. That is a deduction based on 2.2, right? So if EF over AF equals EG over GC, well, let's just have a look at that. So we've got EF over AF is equal to EG over GC. Okay, well, on which triangle must we be working now?
Triangle CAE.
Beautiful, Katleho. You said that absolutely perfectly. Oopsie, me draw. Oh, look at these lines. I'm terrible, aren't I? I really am. Sorry, guys. Trying to draw on this. I don't know what I thought I was doing here, but anyway, let's try and get rid of that one and try and draw it a little bit better. Come on, Lee, you can do it. There we go. All right. So if EF over FA is equal to EG over GC, that means that FG must be parallel to AC, okay, because there's a line that cuts the two sides of a triangle into the same proportions. So that means that FG is parallel to AC, and our reason is going to be?
I don't know.
Converse. Okay, converse proportionality intercept theorem. Okay, so for those of you that were with me when we started this section, all right, one of the things that we spoke about after we did proportionality intercept theorem, we did the converse of the theorem, okay? And the converse of the theorem proves that the line drawn from one side of a triangle to the other is going to be, if it cuts the two remaining sides into the same proportions, that line has to be parallel to the third side. Okay, so now that FG and AC are parallel, now what can we say about C2 and F2?
We can say that they're equal. The angles are equal.
Equal to one another, absolutely. And they're equal because they are what sort of angles?
Alternate angles.
They're alternate angles. Lovely, well done. Okay, so that means that C2 equals F2 because of alternate angles, and that's because FG was parallel to AC. We're almost there. And then we know, we proved that ABCD was a parallelogram in the beginning, so we know that A1 is also equal to C2. So C2 was also equal to A1. They're also alternate angles, but that's because AB, let me just move this up, is parallel to CD. Okay, so if both F2 and A1 are equal to C2, then we must be able to deduce that they are equal to one another. Okay, so therefore F2 equals
A1.
Indeed. Okay, so here, this was out of 5 marks. So they're not going to give us a mark for writing F2 equals A1. That's what they wanted us to prove. So there has to be, I'm sure there has to be a mark on that statement reason. There has to be a statement mark here. There has to be a reason mark here. And I would imagine there would have to be a mark there for us deducing that the lines were parallel because of that deduction. Okay, that initial deduction up here. Okay, Matrix, are you happy with that? Is it making sense? How are you feeling?
Ma'am, question.
Sure.
So since you said that F2, angle F2 is equals to A1, angle A1, and they didn't tell us the parallel lines, is it possible that they give us a question whereby they tell us that the lines are parallel, or are we supposed to find the parallel lines ourselves every time?
Cassandra, it depends on the question. It depends on the question. So sometimes questions are complex like this one. They are problem solving, and that means that you first need to assess what information you've got, decide what it is that you need to prove is equal to something else, and then set about saying to yourself, well, what other information do I need to prove is true before I can actually do that? Okay, so here, in order to prove that C2 was equal to F2 and to A1, we first needed to prove that lines were parallel. Okay, so yes, they can do this sometimes, and then other times they might give you an easier question. But I think it's nice for you to be prepared for both.
Thank you, ma'am.
Okay, all right, so now we need to end off pretty soon because you guys have got to go and do that quiz this evening. Let's just finish off question 2.4, and then you guys can go ahead and go and do the quiz. Our time always goes by way too fast. Okay, so they said if it is further given that ABCD is a rhombus, prove that ACGF is a cyclic quad. Okay, so now let's get rid of all of this, just quickly. Let's get rid of those lines. Okay, so our cyclic quad in this case, let's just do this in blue. Here it is here. Is there anything that jumps out at you immediately, Matrix?
Yes, ma'am.
What jumps out at you, Cassandra?
Can I say that C2, angle C2 is equals to angle G2 because of angles in the same segment?
Okay, angle C2 is going to be equal to angle G2 because of, well, if G2 was equal to C2, that would be true. But because we're proving it's a converse, we can't use the fact that it's cyclic to prove that it's cyclic. All right, so we've got to arrive at that by some other means. You're on the right track. You're on the right track. You're just looking at the wrong angles. Okay, so I just want to show you where you're supposed to be looking. But that was a very good attempt, Cassandra, and you're going to see where you are, what you said forms part of the answer here. Okay, remember it tells us that ABCD is a rhombus. Yes.
Ma'am,
Yes.
can we say angle A and G are supplementary? Does it play a part?
That doesn't play a part in this particular thing. All right, they will be. So angle A2 plus A3 plus G2 plus G1 will add up to 180 degrees. But that's once we've proved that the quad is cyclic. We haven't done that yet. Okay, so again, it's like if you're trying to prove something, you can't say, well, it's true because it's true. You have to say it's true because of other things. Okay, so I know this is not a very nice example, and I teach boys, but this is the one that I always say to them. So like if I'm guilty of murder, I can't be guilty of murder because I'm guilty. I have to be guilty of murder because my fingerprints are on the weapon, or I was the last person seen with the victim, or the victim's blood was in my house or my car. That's the reasons why I have to be guilty of murder. Okay, can't be guilty because I'm guilty. Okay, it's because of other things. And it's the same with this. Okay, it can't be cyclic because it's cyclic. We need to prove it in another way. Yes, Temba. Yeah.
Ma'am, wouldn't you say for the reason why it's cyclic due to the fact that lines AC and FG are parallel to each other?
Okay, but if lines are parallel to one another, does that make it a cyclic quad?
No, not really. I'm sorry.
No, it's okay. It's okay. No stress. I'm not judging you. Okay, so if two lines in a quadrilateral are parallel to one another, you've proved it's a trapezium, but you haven't proved that it's cyclic. Okay, so proving a quad is cyclic, remember, there's only 3 ways that you can do that. So it's got to be converse, angles in the same segment. Converse, opposite angles of a cyclic quad are supplementary, or converse exterior angle of cyclic quad. Always go back to what you've just done. All right, try and use what you've already got, okay, because it's often from that our next solution comes. So in this case over here, what we would see is that because ABCD is a rhombus, that means A1 and A2 are equal to one another. But doesn't A1 equal F2? It does. We've already proved that. All right, so they're both equal. A2 and F2 are both equal to A1, and therefore they're equal to one another, and that's why the quad is cyclic. Yes, Buhle, what were you going to say?
So, ma'am, earlier we proved that AF is equals to CG, so can't we use that when we were doing?
Okay, but we didn't. Okay, so no, because again, if you want to prove that a quad is cyclic, you can only prove it in 3 ways using those 3 converses. So proving that there is a side that's in proportion doesn't prove that a quad is cyclic. Okay, so either it has to be converse angles in the same segment, or converse exterior angle of cyclic quad, or converse opposite angles of a cyclic quad are supplementary. It can only be one of those 3. All right, so in this case, what's happening here is that A1 and A2 are equal because the diagonals of a rhombus bisect the corner angles. So you can see how important your quadrilateral knowledge is to answer these questions. Diagonals of rhombus bisect corner angles. Oh, we need to go so you guys can go and do the quiz. All right, that means that F2 equals A2. Okay, because they're both equal to A1. All right. So therefore, ACGF is cyclic, and our reason for this was converse angles in the same segment. Okay, so here our 3 marks would be awarded for you've got to deduce which angles are equal and the reason. So this line over here, statement reason, that must have been 1 mark like that. Okay. All right. So Anya's very kindly popped the link to tonight's quiz into the chat for you. Please go ahead and go and do that. It won't take you long. And then you're very, very welcome to join us in the next session starting at 6 o'clock.